Bio. We're starting our new chapter today, and the title of this chapter is Populations. So remember, a population is a group of organisms, or a group of the same organisms that live in the same area. So that's what we're going to focus on, is just how basically the interaction of the same organisms works within a defined space. And so our first section is going to be how populations grow. So it's going to be how these different groups of organisms that are living in the same area, how can they actually grow. But before we start, we have to look at what characteristics are actually used to describe a population. So in order to understand how they grow, we have to understand what in the heck a population actually is. So the characteristics of populations, so there's three important characteristics of a population that need to be looked at when you kind of examine it, and those three are geographic distribution, density, and growth rate. So we're going to take a more close look at each one of those, but those are going to be the three things that are really going to define what a population is. So the geographic distribution is just the range is another way to describe it. Simply describes the area inhabited by a population. So it's simply the area that the population lives in. We kind of mentioned that with biomes earlier, what geographic distribution is. And then population density, so this is going to be, again, another important one to know. This is the number of individuals per unit area. So that's just simply saying there is 5 people in this 1 square mile of area. That would be the population density. There's 5 people living in this 1 square mile area. That's what it means per unit area. Or it could be there are 12 fish living in that 37-gallon fish tank. That could be, again, the population density of the fish tank. And then growth rate is simply the increase or decrease of the number of individuals in a population over time. So it would be things, new organisms being born, while the old organisms are dying off. So that is the growth rate. So whether the growth rate is kind of maintaining an equal balance, or it's increasing, or it is decreasing. And so going right along with the growth rate is what factors are going to affect population size. So the 3 factors, which again kind of alluded to this just in a second ago, would be the number of births, the number of deaths, and then the new one that I didn't just mention would be the number of individuals that enter or leave the population. And then the next one, this is just kind of some self-explanatory stuff here, but a population will grow when its birth rate is greater than its death rate. And so those 3 things are going to all be in a factor on whether or not populations are growing or not. And to go along with the last one we just mentioned with the number of individuals that enter or leave the population, so a word that describes movement of individuals into an area is known as immigration. So this is always kind of a hot topic issue right now in the news. So immigration is the movement of individuals into an area. Again, it's just another factor that can cause a population to grow. And then populations can increase by immigration as animals in search of mates or food arrive from outside. So there could be a group of geese living out on your pond, out in your backyard, and let's say a new group moves in and they all just decide to stay there because there's enough food there, or they think they could possibly actually have a mate there. So that's what a population is. Or that's what, immigration is. And so then the opposite of that, it's pronounced basically the same way as immigration, but just for maybe the sake of not getting confused, we'll just call this emigration, or emigration, but it's pronounced the same, immigration. But it's the movement of individuals out of an area, and this can cause a population to decrease in size. And emigration can occur when animals leave to find mates, kind of the exact opposite of what we just said, and establish new territories. And then also, again, a shortage of food in one area may also lead to animals moving out. So those can also, birth rate, death rate, immigration, emigration, can all affect whether or not a population will grow. And so when we talk about growth, there's 2 different types of growth that can occur in a population. So this is going to maybe be a little math class review here, that there's exponential growth and logistic growth. So we're going to need to know the difference between these 2. So that's going to be an important thing to know. So first one is exponential growth. So under ideal conditions with unlimited resources, a population will grow exponentially. And what that means is that individuals in the population are going to reproduce at a constant rate. So again, there's unlimited resources, they're going to continue to grow, they'll reproduce without anything ever kind of getting in their way, and the population will become larger and larger until it approaches an infinitely large size. So it literally will just continue to grow forever and ever if there's unlimited resources. And here's what the graph would look like. So if you look, you can see they just have the number of bacteria versus the number of elephants. It's obviously over a longer period of time. But if you look, all of a sudden the curve just shoots straight up, because that's when all of the organisms are just starting to reproduce without any competition, without any resources. However, exponential growth almost never occurs in nature because there is never unlimited resources in nature. And if it does happen, it will not continue for a very long time, so there might be a short burst where it goes through that exponential growth, but it will never occur forever. And as resources become less available, the growth of the population will slow or stop, and when that happens, logistic growth occurs, and so that happens when a population's growth slows or stops following a period of exponential growth. So again, exponential growth is when it just takes off, huge numbers, and they're constantly reproducing, constantly making more, but again, that cannot happen forever because resources are not unlimited. So once it does finally top off, logistic growth occurs, and then that's when what the curve would look like. Again, we can see when you still have the number of organisms right here at 6, 12, then it just shoots right up, and then it kind of levels off right here, and that is what logistic growth is, when it levels off there. And another word to go along with logistic growth is the carrying capacity, and the carrying capacity of a population is the largest number of individuals of a population that a given environment can support at any time. So our environments, again, if they can only hold 10 rabbits successfully, then that means the carrying capacity is 10. So if that's just based off what their resources are. And when a population reaches the carrying capacity of an environment, the growth will level off, and then the average growth rate will then become 0, because again, it just cannot support any more life. So that's it for section 1. Let me know if you have any questions.